In this video, we're going to talk about applying the difference quotient. In this case, we're going to talk about using it to get an average rate of change for various intervals of size h, starting where the interval starts at some value a for some function. So we're going to do ours for f of x equals 2x squared minus 1. We'll have our interval start at 2, and we'll just do it for 3 h values. I think you'll kind of see the pattern after that. So our difference quotient, as a reminder, in terms of a, is f of a plus h minus f of a all over h. What this does is this calculates the average rate of change between a and a plus h, because on top we have our change in output, and on bottom we have our change in input. Now it may not look like it, but this is the exact same formula you use for slope. Rise over run. Well, let's see how that applies to our function here. So, first off, we have to figure out what f of a plus h looks like. Well, we're using a equals 2, so we have f of 2 plus h minus f of 2 all over h. So we need f of 2 plus h, we need f of 2, and we can put this thing together. F of 2 plus h, that is our function with 2 plus h plugged in for our input. So we have 2 times 2 plus h, the quantity squared, minus 1. And there's our f of 2 plus h right there. Minus f of 2. Basically, that's our function evaluated at 2. Now I'm going to write it like this, just so you can see where it comes from. 2 times 2 squared minus 1. And you do always want to put that in parentheses. So there's my f of 2 right there. All over h. Now we got some work to do. So, first thing we need to do, this needs to be FOILed out. Alright, it's 2 plus h times 2 plus h. So I have 2 times 4 plus 4h plus h squared. If you're not sure where that comes from, do 2 plus h times the quantity 2 plus h and FOIL it out. Minus 1. And then here we have 2 squared, which is 4, times 2, which is 8, minus 1, which is 7, so minus a 7 at the end. All over h. Now, I'm going to distribute this 2 and combine like terms. So I'll have 8 plus 8h plus 2h squared minus 1 minus 7 all over h. Now we got some canceling because we have a positive 8 and minus 1 minus 7 goes away. And now I can actually factor an h out of the numerator. So let's move this up. So I've got h times 8 plus 2h all over h. And those h's cancel. And I get all the way down to 8 plus 2h. Now I can just plug in my values that I was given for h to get the average rate of change between 2 and the point that is h units away. So we were asked to do it for 1, 0.5, and 1. So for when h equals 1, we get 8 plus 2 times 1, or 10. Now remember what that is. That is the average rate of change between where we started. We were asked to start at 2 and a point that is 1 unit away from 2, so 3. H equals 0.5, so 8 plus 2 times 0.5, that equals 9. That gives us the average rate of change over 2 and 2.5. Continuing on with this, h equals 0.1, So we get 8 plus 2 times 0.1, which equals 8.2, and that's the average rate of change over 2 to 2.1. And we can keep going with this. We can make our interval any size, and this will give us the average rate of change. What you can probably tell is as this gets smaller, if we made h be 0.001, we'd get an 8 plus 2 times 0.001, or 8.002 over 2 to 2.001. So we're getting a really small interval. In fact, this allows us to estimate our average rate of our instantaneous rate of change at 2. Our instantaneous rate of change would be 8. We can kind of see that by plugging a 0 into what we found from the difference quotient.